SANZA's mandate is to ensure that all the benefits of space science and technology are brought down to the local community. So there are many government departments that use satellite information to make decisions. It's essentially an agency that provides the data sets and the processing capabilities.
On 3, 2, 1.
How are we going to do this?
Early in the next decade, a set of crewed flights will test and prove the systems required for exploration beyond low Earth orbit. And by 2025, we expect new spacecraft designed for long journeys to allow us to begin the first ever crewed missions beyond the moon into deep space. We'll start by sending astronauts to an asteroid for the first time in history. By the mid-2030s, I believe we can send humans to orbit Mars and return them safely to Earth. And a landing on Mars will follow, and I expect to be around to see it.
We are interested, but I think what we need to do is to get the high-level indication from government, whether they support this or not. Because it is an expensive exercise. You can pay up to, what, $20 million for a ride on a launch vehicle. So, you know, if we have a South African astronaut going up, it will be an inspirational factor. I don't think we will be able to do that with anything else. We did have launch capabilities, and we did do successful launches from South Africa. The outer space principle applies to even planetary bodies, because South Africa can't land on the moon and say, this is our territory, because it belongs to America. So the key question is then, if country X spends a lot of money going to, let's say, a planetary body and gets back material, what is the implications? Various programs. At the moment we have 4 programs. It's space science, satellite engineering, Earth observation, and then space operations. So if you look at satellite engineering, there's a lot of development work that happens in the satellites. We actually develop some of the components ourselves, rather than rely on international suppliers for that. And then in space science, there's a whole host of researchers that we employ to do research in space physics, to understand the outer space environment, the space weather phenomena, and so on. So there's a lot of R&D work that's happening inside of SANZA.
Think about space technology is, I think quite often when you talk to someone in the public domain, you tell them about space, and they think about spacecrafts, and they think about rockets, and they think about, you know, planets and going to Mars and that type of thing. But space is more than that. I think the greatest benefit that we've derived from space is actually looking from space onto our planet. And this is where the underlying depth lies in space technology. And it usually happens through satellite technology, you know. But a picture has more than 1,000 words. In fact, a picture has so much of depth in it that you can learn a lot about, you know, your country, can learn a lot about the planet. So satellite images in particular, within the Earth observation area, tells us about our planet. As an example, if I give you, if you look at water bodies, and a big problem now that we have in Cape Town, for instance, we have a water problem. I mean, if you use images from satellites, you'll see that you can actually see the pattern of the water bodies getting smaller and smaller and smaller through satellite images. And that type of information enables us to take certain types of decisions. There are other examples, for instance, human settlement, urbanization. If you don't know, by 2050, 80% of developing countries will be fully urbanized. So it allows us to plan better. So if we can see a movement of people into a particular area or new settlements being developed, you can make sure there's provision of electricity, water services, the necessary essential services to ensure that we look after our people in the country. I think we start to achieve a more prosperous society.
One of the important points around this is that South Africa will be hosting the Pan-African University for Space Science Institute. So whether you want to do Earth observation, navigation and positioning, or telecommunications, or building satellites, there's a number of universities in the country where some of these modules are offered, and students from the rest of Africa will come to South Africa to study those, and then they will go back home. So we will support even the students as they go back home in terms of the national programs.
So basically we use remote sensing data to manage crop. We get information on the Earth's surface, feature, or even other phenomena that without being directly in contact with it. Sort of yield prediction and disease detection, basically it's something that's a major challenge with regards to disease detection. It's a major challenge for farmers. Small-scale farmers, because they sort of lose a lot when their crops are diseased. So we could deal with issues like food security using remote sensing.
We protect and conserve the environment. We use satellite imagery, remote sensing to monitor our natural resources. So basically that's your multispectral sensors, whereby you have a snapshot of Earth, and we know what is where, and so we can conserve our natural resources and protect the environment. Yeah. We use these type of technologies to monitor illegal activities in our protected areas. If there's illegal activities being carried out there. We also use it to monitor air quality, for example, and air quality and the toxic waste that comes out from your landfill sites. For example, one case was when we had a landfill site, and it was, the waste from the landfill site was seeping down a valley and into our rivers, and communities were using the water to obviously to drink, wash their clothes, and they breathe that air, and that can be toxic to them. So by having these technologies, we can better protect our environment, make informed decisions, and ensure that the general public is complying to environmental laws. The ones with socioeconomic benefits and health benefits I mentioned, the toxic waste that's going down, we use satellite imagery as backdrops to determine where the waste is coming from, how it's affecting the people. We get that data from sensor.
The value of Earth observation is that it beats taking the observations from the ground. So if you want to measure anything on the ground, you could either do in situ measurements, but that takes resources, okay? Because the problem with in situ measurements is very localized. And some of the issues that we're looking at, it even extends beyond the country borders. So spatially it's very large. Like if you look at climate change, if you look at the weather patterns, it's not just South Africa, it's the entire region, okay? And that you can't do from the ground. You need satellite information. So just to give you a sense, the climate change, the essential climate variables, you can't do that without space. In fact, 80% of the essential climate variables come from satellite technology.
Currently we're using National Geospatial Information images, which are aerial photographs, 0.5 meter resolution. The only challenge we have about those images is that they are not frequently updated, and then there are so many changes that happens in the coast. Sensor has the spot images and then Landsat. My name is Matwani Joyce Nengwenani, and then I've studied environmental science at the University of Venda. I'm currently working for the Navy, Department of Defense.
We actually have 2 mobile vehicles, and so these are little mobile vehicles that open up. So when you get to a school, the panels open up on the side, and there's experiments that are conducted on the vehicle itself. So the school kids gather around it, and so especially if the school doesn't have laboratories.
Yes.
And so we've got 2 of those mobile vehicles. Obviously, we want to have a lot more. And we've also have people that are focused in terms of training on in the schools themselves. We also have a sort of a science center in the Western Cape, in one of our centers, where the students actually come to the site, Sansa site, and we have facilitators on the ground that then take the students through in terms of what space is and what is the various issues around space weather and so on. So we do provide in-house training. In fact, just late last year, with the private sector, there's a number of private sector companies that are involved in science awareness. And so we started to partner with them to work side by side.
Science for today and for deep space exploration tomorrow.
Because we went through a whole process of disbanding our nuclear capabilities. And when that started to happen, our space capabilities also gave way. Because when you have a launch vehicle, you can use it to take a satellite into space, but you also use it to deliver a nuclear weapon.
Yeah.
When you kill the nuclear program, you kill half the space program as well. We're building a satellite at the moment. This is an engineering project. And we're developing our IP. So we have a company who's a prime contractor that's building the satellite. But because of the funding that we've given them, there's a lot of R&D. But that R&D is also, they're subcontracting other industry players to come and assist in developing the satellite. Sansa owns the IP, not the company. Okay. And then if you're building, let's say, the next satellite, which is a different prime contractor, then that IP will be made available to that industry player. And we're also now starting a discussion where many countries are looking at South Africa to co-develop a satellite with them because they want to learn and gain access to our IP. So we've already in discussion with our National Intellectual Property Management Office, around licensing agreements that we sign off, where we share IP, but also protect our IP as well.
It will be our second satellite CubeSat. The first was ZECube-1, this is ZECube-2. But the intention of this program is quite exciting. We eventually will have 9 satellites that will be orbiting the planet and essentially keeping an eye on our ocean and making sure that we take care of any potential security or risk within our ocean. We have a space weather center, and there are several impacts that the space weather has on our country. Communication, the aviation sector, the power grid sector. So the only African country that has a space weather center, and the space weather center will provide intelligent information about what's happening in space to various industries. It is in fact going to become a requirement under the aviation sector to have space weather information as part of your flight planning policies and strategy.
There's a space studies program at UCT. There's the National Astronomy Space Science program, which is at UCT, Northwest University, UKZN. And as I mentioned, with the Pan-African University for Space Science Institute, and that's looking at developing satellite engineers. There's also a program at Stellenbosch University. So with a number of engineering departments across universities to see what is the appetite to do space engineering. Obviously, it depends on the university themselves. We can't force it into them. They have to be willing to take it up. And we've seen aspects of that. I mean, CPUT started a completely new space engineering, satellite engineering program less than 10 years ago. And today they're very successful. Up until this moment, the funding has been limited, which meant that we couldn't do as much as we wanted to. But what we've done, so I'm fairly new, I joined in 1st of January last year. And what we started to do was to relook at all of our plans. And so we've essentially expanding in terms of going now into satellite communications and navigation augmentation systems and so on. And we also now have a bigger focus on external relationships, especially developing the industry. In fact, we put a plan together to develop an industry development framework, which we will start implementing as of the 1st of April. And that's to draft a development framework for the industry. So we're moving, I think, in the right direction in terms of building the community, building the ecosystem. So the next few years will be interesting. bad.
We generate our own electricity. We have a generating station down the valley there. It supports both farms. It supports us, and it supports also the Radio Astronomy Observatory. To support the teleport, we've also now put dark fiber onto the site. The deep space missions as well that were supported down the valley in the Radio Astronomy Observatory.
Well, for mapping and charting, we switched over this is also the outer beers, but it's also the setting of the datum for a World Geodetic system. Yeah.
Which one is the Airbus one actually?
No,
there is no Airbus.
It doesn't belong to Airbus.
Yeah.
It belongs to us.
And if there are rare minerals that's not on Earth, then it makes sense. And if there's a use for it, then it makes sense.
Yeah, you know, when you think about the fourth industrial revolution, everybody has a different understanding of it. For me, the fourth industrial revolution is really is the connectedness of many things: the physical, technology, the biological, everything connected. And what does that mean? We quite often hear about smart systems, smart homes, smart energy. Now, all of that is in the domain of the fourth industrial revolution.
Right now, we see that it can be very much beneficial. It can even cut costs in terms of relying on the field workers for them to go and collect data. What is it that has changed? We can automatically see it from the images and update our charts.